Discover South Carolina presents The Palmetto Porch, a podcast featuring some of the most uniquely charming destinations across the Palmetto State. I'm Devin Whitmire. Join me as I find out what's off the beaten path as I speak to South Carolina locals who know their towns best. Find The Palmetto Porch wherever you get your podcasts. And for more information about our show, visit scpalmettoporch.com.
Hello, everybody. Welcome again to JavaScript Jabber. I am Steve Edwards, the host with the face for radio and the voice for being a mime, but I'm still your host. With me on the panel today, we have what do I call you? Always handsome? I don't know. AJ O'Neill. How you doing, AJ?
Yo, coming at you live from a nice cold can of Mountain Dew.
In a purple room, by the way. Oh, that's just your light. Never mind. I always forget that. And also on the panel, we have Dan Shapir. Hi, Dan.
Hi, coming to you from Shai's recording studio.
Speaking of Shai Yalin is our special guest today. So you want to introduce yourself, Shai? Tell us who you are, why you're famous, what you do, and all that stuff.
Hi, so my name is Shai Yalin, and I am an independent software engineer. I've been doing that for the past couple of years, working...
That's an understatement.
No, I for the past couple of years, I have been an independent software engineer.
Yeah.
And before that, I had various roles in software industry in Israel, mostly at Wix.com, which I joined at 2010 when we were like 20 engineers, and I left at 2017 when we were something like 1,000 engineers. I was a founding member of the Wix backend engineering guild, and among other things, I introduced TDD to Wix. I moved Wix from the Java language to the Scala language, which runs on a JVM. And I helped create the engineering culture that I hope is still alive in some version today at Wix. And because Wix was such a big company and a lot of talent has left the company over the years, I had ripple effects on the Israeli software ecosystem. A lot of companies have ex-Wixes who followed my methodology to some extent.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
Yeah, that's totally true. So I met Shai at Wix. I joined after Shai. I joined in 2014. So you were already at least 4 years there when I joined. And undoubtedly, Shai had a really big impact on the development culture and methodology at Wix. I remember receiving a book that you kind of made a mandated reading when I joined. Can you remind us what the book is?
Yeah, it's Growing Object-Oriented Software Guided by Tests by Ned Price and Steve Freeman, or Goose, as the TDD guys call it.
And I know that at Wix, you primarily had an impact on the back end because, like you said, you were a founding member of the backend guild. But interestingly enough, I think that these days you're mostly involved in front end stuff. And when we talked about it, you actually also told me that you have your own personal roots, I think, kind of in the front end space before you kind of switch to the back end and then back. And now you recently wrote an article about a side project that you did in the front end domain mostly, but that kind of And again, I witnessed the methodology that you used, and I thought that it would be a great topic to discuss this kind of a methodological approach to software development on our podcast.
Yeah, cool.
So yeah, the post that Dan's talking about, we should sort of use as a jumping off point today, regards your creation of a side project called Chronomatic. It looks like it's a sort of a time tracking and budget tracking application. So I guess let's start out with talking about what that project was. What was the itch that you were scratching in creating it, and then how it addresses some of the other issues you wanted to talk about.
Cool. So yeah, as Dan said, I've been developing for the internet since I think the early 2000s. I did work on ASP servers and then PHP servers, Java, PHP again, Python, then a lot of Java.
All the good stuff.
and then in 2015, I joined the Wix innovation group, which was trying to rebuild a new rendering engine for Wix. And they were the first group inside Wix that adopted React as the framework for the components that Wix render. And we built something together. We did it TDD, and that was before React testing library. That was before Enzyme. Enzyme was introduced when I left the group for a different role. And so I have been doing front end in one way or another for the entirety of my career. But I never really did it alone. I never had the opportunity to dive into things alone. And now, a couple of years ago, I became independent. And now what I do is I help my clients deal with software that is harder to change. So software that doesn't have enough test coverage, software that was written hastily, quick and dirty style. And then, after a few months, the quick part is gone and it just have a ball of mud. So I step in and I help my clients, untangle the mess, that's the ball of yarn. And so, as I said, I'm an independent contractor and I have to manage my own hours. So I work either remotely or on site with my customers. I never work alone. I always work in pair programming with an engineer that works at my clients. So they assign someone to me and we start to, refactor the software together, introduce some tests, refactor, introduce more tests, do some more refactoring, and eventually they learn my methodology. So what happens is that I have very specific needs for time tracking because I don't work individual hours. I sell prepaid bundles of hours to my clients, and then I have to track both how much time is left for each client and how much time they paid for. And I tried several time tracking systems like Clockify and other systems, but they were all too big for me. They were all aimed at, teams of developers, and I'm just me. And I never want to be more than just me. I don't want to be a CEO of a software company. I want to be just me consulting. So that was one part of the background. The other part of the background is that I had to relearn a lot of technologies when I met new customers. I knew some React, but I never did, functional React before I started consulting. And then I have a customer that is doing serverless. So I had to start diving into, Firebase and then Hasura, which is a serverless GraphQL system. And so I had to learn how to take my proven methodologies, my proven approaches to doing software in TDD and adapting them to a world where you have Firebase and that's it, or you have Hasura and that's it. And how would you TDD a React application with Hasura as a backend? How would you TDD a React application with Firebase as a backend? And since all of my clients or most of my clients already have, balls of mud when they call me in, I really wanted to have the opportunity to create, my ideal experience, my ideal guideline for how would we create a software system based on React, for instance, with Firebase as the backend, for instance. So the two parts of the background really met together. And so I took a couple of weeks off my clients and just dove into the development. And while I was working, I was also documenting what I was doing, that when I wanted to blog about it, it was, really easy to just form it into a blog and just reason about what I was doing, why I was doing what I was doing, the choices that I made, and so on and so forth.
Because you mentioned it a couple of times during your this explanation, and because some of our listeners might not be familiar with it, especially the more junior ones, can you elaborate a bit about TDD, what it is, how it's used, why it should be used?
Yes. So TDD is a very, ambiguous expression, a very ambiguous concept. A lot of people talk about TDD. I have read a lot of very negative opinions from people about TDD. There have been several noisy and active discussions on the internet over the years about TDD and its applicability. So I wanna talk about like what I call TDD.
First of all, what does TDD stand for even?
Yeah. So TDD is test-driven development or test-driven design, which is the term that I prefer because it's not about developing software. It's about evolving a changeable design.
Cool. So effectively it's, to put it bluntly, or correct me if I'm wrong, it's about writing the tests before you write the code and then writing the code in order to pass the tests. And then after you've achieved that, you write more tests and more code and rinse repeat, correct?
That's the mechanism, but it's not only that because, how do you know which test to write? How do you know what is the next test that you're going to write? So TDD is about introducing requirements into a system in form of an executable specification. So you have a requirement. And let's talk about how you start a system with TDD.
Cool.
So you have no system. You have a requirement. I want a system to be able to track time. So the first test would be when I click the start timer button and then I click the stop timer button, an activity has been registered with a duration of 0 seconds. Or almost 0 seconds. So I write that test. Now, the first test for a system would usually be in the approach that I'm using. It would usually be an end-to-end test. So I would start up something like, Cypress or Puppeteer or Playwright, which is what I ended up using. And I would write a test that browses to localhost and then logs in and then starts the timer, stops the timer, and then clicks the activity and checks that the activity has been registered with the data that I expect it to have been registered with. Now, this test is going to fail, right? Because there is no system. So to make it pass, I need to create a very thin system with almost no implementation that only makes this test pass.
So just to clarify, when you write this end-to-end test, and I'll get back to that in a second, effectively localhost might be a blank screen or is a blank screen. You're saying, the end-to-end test presses a button, but there is no button yet at that point in time.
There is no server listening at localhost 3000 or 8080 or whatever. There's nothing. There is no system. So this test fails because it gets connection refused from the port that it tries to browse to. And then bit by bit, you make it pass, you make it fail less. So you get 404 instead of connection refused and so on and so forth.
Now, I don't know if it's because I was first introduced to TDD in the context of system programming rather than front-end programming, but I was always used to TDD as a mechanism in which you write really small tests. So kind of unit tests to begin with. And it's really interesting that you're actually taking the totally opposite approach of writing an end-to-end test in order to begin with.
Yeah, so the approach I'm using is very similar to the approach in that book that we talked about earlier, Goose. And there are two schools of thought in the TDD ecosystem. They call them the Detroit School and the London School, but I don't really care about the names so much. For me, it's the approach that starts with an arbitrary piece of software that is not specifically like the system. So it starts from the inside and then it grows the system towards the outside. And the alternate approach, which I'm using, is outside in. So you start, every test is a black box test, and every test knows nothing about the implementation of the system that it tests. For instance, my end-to-end test doesn't know that my system uses React. It doesn't know that it uses Firebase. It knows nothing about the system. It just goes to localhost port 8080 and expects there to be an HTML page. And then it interacts with the page using JavaScript. But it knows nothing about the implementation. And when I write the next tests, they're not going to be end-to-end tests anymore. They're going to be tests in a more deeper layer of the system. But they, again, are going to know nothing about the system the subsystem that they are testing. So every test is a black box test. This is the important principle.
So when you have that end-to-end test in place and you're starting to implement the code in order to pass it, draw the button, introduce the button event handler, have some object on which you trigger the start and the finish and whatever way in which you implement it. For all those pieces of code that you're implementing, are you also kind of creating, let's call them quote unquote micro tests? Or how does this outside in type of approach actually play out in practice?
So my answer is going to be maybe, because let's think about each test as a requirement. Now, a requirement could talk about a feature being in existence, or it could be about a property of a feature. A requirement could be you can start the timer or you can start the timer again. You can resume the timer. Or a property can be that when you resume a timer, the client ID from the previous timer is going to be duplicated to the resumed timer. The second test is much more specific. So it can be in a much deeper, more nested layer of the system. So it can be more of a micro test. Generally speaking, in TDD, you do the TDD tests to help tease out the system using requirement after requirement. You do refactor after each test, which is very important. TDD is about refactoring. Like, tests are nice, but the main value of TDD is that it gives you good opportunities for refactoring, and you're always safe because you always have test coverage for everything.
It's important to emphasize that when you're tests by definition are kind of a requirement, at least from my perspective, in order to do any sort of modifications or refactoring in a system. It's just that with TDD, you can do it while you're implementing the system. It's not like you're implementing a certain part of the system before you have any tests, and then you write the test, and then you can modify that part. It's kind of like that story about Linus Torvalds, who wrote Git and started using Git while he was writing Git, and basically he was done when all of Git was in Git. So it's kind of this approach that you're safe while you're still in the, let's call it the investigative stage of trying out the various different approaches.
Yes, and I think it's very important because from my perspective, software always changes. There is no done in software. No software is ever done.
Unless it's dead.
Yeah, exactly. If it's done, then it's dead, and you shouldn't be changing it anymore.
Well, we want software to be done.
No,
I take exception to software is never done. You can define a set of requirements, and you can say, this takes this input, it gives this output. The input and the output are correct for this part of the system.
This software is dead software because the company can't live off of that software anymore. Because if the software is done, nobody will actually pay maintenance or licensing or whatever on that software, potentially.
Well, that's an economic problem. That's not a computer science
life
problem.
Is an economic problem.
I think
that's
we're
true.
Talking about different things. I think Dan is talking about the features, and AJ is talking about functions or classes or modules, parts of software. Now, parts of software can be done, but the system as a whole, like, when is Facebook done? When is the Google search?
I think Facebook was done 5 years ago or so. Do you know anybody that uses it?
They just don't know it yet.
I think they know it. Isn't that why they bought Instagram and WhatsApp and TikTok? No, TikTok's Microsoft, or who owns TikTok?
No,
now?
TikTok is the Chinese government.
Yes. So
10 cents.
Yeah. So in general, software always changes, and when software does not change anymore, it's dead. You said it yourself. Facebook is dead, right? Nobody wants to be on Facebook anymore. So the need to change it might go down. But now they have like a gazillion engineers on board, so they will probably keep changing it, but the requirement might not be there anymore. Software always changes as long as the requirements change. And TDD, if done right, can help you always be able to change your system. No matter how difficult the new requirements are in comparison to the existing design.
I want to push back slightly because that sounds really similar to communism when done right. If you have to when done right, every system when done right is gonna
Yeah, but it's much easier to do TDD than communism because, although both kind of go against human nature in some sense, but it's easier to do TDD because, you don't have Stalin in TDD.
Well said. No, but I'm being a little bit devil's advocate. I do believe in TDD to some degree. If you can define the specification really well and you know the inputs and the outputs, then I think that TDD makes a lot of sense.
You don't have to know the specification well at all. On the contrary, the whole point of TDD is helping you do the investigation stage and again, it goes like a bit to the concept that I was talking about earlier that, software always changes. Another way to say the same thing is to say that you're always in maintenance mode, right? A lot of engineers...
Those are two different things, though, because maintenance mode is you're just fixing bugs. Maintenance mode is you did a weekender, you put a product together, you got funding, and now 2 years later, you can't rebuild it because it's too fragile. And that's when I think maintenance mode, I think really complex, fragile software that someone has to be around because it always breaks in some subtle way. That's what maintenance mode means to me.
To you, but to a lot of people, that's the day-to-day is maintenance mode. I started a product at Wix.com that is still alive today, like 10 years later. And some poor bastard or some team of poor bastards have to maintain the software that I wrote because the entire company is reliant upon it.
I'll take it a step further. One of the amazing things about Wix while I was there is that Wix has this concept of the Wix viewer, which it's like the heart and the core of Wix. When you build a site using Wix, the Wix editor, and that gets saved as a bunch of JSON files, effectively, that kind of describe the website semantically. That needs to get translated at quote unquote runtime into the actual website, the HTML, the CSS, and the JavaScript that makes it run. That operation is handled by the Wix viewer that, as Shai says, at least the last time that I checked, was written in React. But the interesting thing is that this core aspect of Wix, the thing that all of Wix runs on during the past something like 8 years, has been rewritten something like 3 or 4 times. And not just minor changes. I'm talking about a rewrite. And that was only made possible due to the fact that there were so many tests, or mostly end-to-end tests, but not just, ensuring that those rewrites actually satisfy the requirements, the main requirement being that it needs to be compatible with the previous version, because there are hundreds of millions of websites that are dependent on that, because you can't release a new version of Wix and all of a sudden all those hundreds of millions of websites look or work differently than they did before. They have to look and work exactly the same. And by the way, I mentioned the fact that it's built on React because Wix is built with React. When something like the Crux, the Google database, counts websites and analyzes them according to the technologies that they use, 25% of all React sites in the world are actually Wix sites. So Wix accounts for something like 25% of React usage as websites, but not by traffic, but by domains. So that's kind of an interesting aside.
With a very, very long tail.
Yes. There are Wix sites that have been built something like 10 years ago. Nobody has touched them since, and they still look and work exactly the same even after those 4 rewrites. And that, to a great extent, was thanks to that methodology of TDD. I don't think, though, that anybody would argue with the value and the need for tests. I think that where most people falter is with either the approach or the dedication or whatever you choose to call it, of always writing the tests first. People, at least for me, a lot of the time kind of ends up that, hey, I'll just write this functionality. And when it's done, that's when I add the test to verify that it works correctly. And then if I change it, well, then I have the test. I think that where most people falter is with writing all the tests in advance. Would you agree with that, Shai?
Yes. And I think a very interesting point to discuss after we give the other guys some time to
digest.
to maybe say something, is why should we write the test first? Like, what's the value in that?
Well, I would assume that you know ahead of time what you want your application to do, right? You want it to look like as you have a design, right? You've gotten, if it's a website and you've gotten a design from somebody and you know what you want your functionality to be. And so your test is basically your tool to make sure that it's doing what you want it to be. This is, of course, assuming you're not in an organization, as I have been before, where your methodology tends to be ready, fire, aim. Just start working and then we'll figure out the rest later.
Actually, TDD is very good for this kind of approach.
So, but anyway, it's basically a constraint to make sure that you're doing what you expect it to do. That's how I see the test-driven design, because if you write your tests to say, okay, I'm expecting this and this and this, and then when you actually run the code, it doesn't do that and fails, then that tells you that you are not, your application isn't doing what you expect it to do. Now, that being said, there can be legitimate cases where there's a reason that it's not doing what you expect it to do and it can't. And so then, therefore, you might need to adjust your test instead of adjusting your code. But to answer your question, that's what I see the value or the goal of TDD is making sure your application is doing what you said it needs to do.
So what Steve said that he was working at an organization where they were doing ready, fire, aim development. Just start working and see how it goes. I think TDD excels at this kind of situation because, like, in contrast to what a lot of people think, you don't need to have any design upfront. Nothing. You take whatever feature definition that you have and you translate it into a test, and then you make this test pass. What do you gain by that? First, you can do a proof of concept, but this proof of concept, you know that it works because it makes a test pass. It conforms to a contract. It satisfies some requirements that have been encoded into runnable specification. In my case, in, Jest, but, it can be anything. It doesn't really matter. It could be Puppeteer, it could be Cypress, it could be React testing library. It doesn't matter. You encode a piece of requirement into an executable specification, and then you implement it. Now, so if you're trying to do some, probing or some research, you can do it with TDD. And you know that whenever you're going to present something to the founders, to the design partners, to alpha users, whatever, you know that what you are promising is actually being delivered because tests have been written before the code, because no code has been written unless it was in order to make a failing test pass. And this is very important because if you only write code in order to make a failing test pass, all of your code is by definition covered. You have full coverage. Even if your test coverage tool might say otherwise, all of your code is covered. And then you can always change your code. You can also refactor your code, or you can always reason about new features and how they fit with existing features. If you might want to change an existing test to maybe refine it, make it more specific, make the feature more nuanced as you go along. You change the test starts to fail, and then you implement stuff in the code to implement this new nuance. You didn't even introduce a new test. You evolved an old test. But the main thing is that you're only writing code to make a failing test pass. And if you do that, then you're not doing any YAGNI, any code that you don't need to write. YAGNI stands for you ain't gonna need it. And a lot of software is over-engineered, has bits of things that people put there because they thought they might need it in the future. And then when the future comes, then these are not the droids that you are looking for. This is not the software that you actually needed to write. You needed to have something else, but you didn't know that in advance because you cannot see the future. So you thought that the way to make your software changeable in the future would be to generalize, a few bits of things, to introduce some abstraction, some layers of indirection, and then 3 months later, you come back to a piece of code and you find out that you have to break an existing indirection, an existing wrong abstraction, and introduce a better abstraction instead. If you did TDD, you wouldn't have to do that. You wouldn't have introduced an abstraction.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
So I have a couple of questions about the practical aspects of this. One is that, again, you described how you do this outside-in type of approach, which means that you start with an end-to-end testing framework, but eventually you do work yourself in. So at one point or another, I assume that you start using testing infrastructure that's appropriate for unit tests. When do you kind of cross this chasm? When do you actually start doing those specific tests of let's call it small sections of the code?
So in general, my guideline is I have an end-to-end test for every epic, for every big feature. So if we are talking about, for instance, an e-commerce website, then you're going to have the part of the website where the users, the shoppers, are browsing. And then you're going to have the parts of the software that the store owner is using, right? So store owner edits the catalog, edits the inventory, fulfills orders, and the user places orders, adds products to a cart, converts the cart into an order, sees the thank you page. So in this kind of use case, I would have 2 end-to-end tests. One for the store owner and one for a customer. And each of the end-to-end tests would tell a complete story, a very simple story, a very coarse-grained story. So for instance, an end-to-end test for a shopper would be, I add the first product in the product list into the cart, and then I pay using the default payment method, and then I expect to have gotten an email with the order details. That's it. But think about the scope of this testing. It encompasses a lot of different parts of the system, but it says very little. It doesn't say anything about the product, not about the price, not about which product is that. It doesn't care about that. Now I want to dive in. I want to say, a user should be able to search for a product. You want to search bar. Why didn't you say so? Let's write a test that expects a search bar. Now this test is not going to be an end-to-end test anymore. Why? Because I already have an end-to-end test, and adding search is not a new story. It's not a new epic. It's a variation of an existing story where I want to buy a product. So I would create a test for just the React application if I'm using React. So I would use React testing library. I would render the entire application, the entire store, and I would interact with the store using React testing library. And I would use something called hexagonal architecture to allow me to have each test independent of other tests. So each test renders the entire application with its own data set, with its own products in the case of a store, where all of these tests are running in memory. So if my store uses, for instance, MongoDB as a database, my end-to-end test would use MongoDB, but my React component tests would not use Mongo. They would use in-memory repository pattern, in-memory data access object.
So effectively for the unit tests, unlike the end-to-end tests, you're creating mocks for the external services on which you might be dependent.
No, I'm not using mocks. I'm using fix. It's not the same thing.
Okay. Can you explain, please?
Yes. So we're talking about test doubles. The pattern is known as test doubles in the, software engineering testing community. And we have 3 types of test doubles. We have a stub, a mock, and a fake. A stub is something that implements an interface, whether it's, a Java interface or an implicit, TypeScript interface. It doesn't matter. Or even a Java interface, a JavaScript interface, or it doesn't matter. Like, it implements some expectation, but it doesn't do anything. It's like the minimal code just so that we don't have any compilation or runtime errors.
Kind of like a dev null.
Yes, yeah, it's just there to make things work. Then you have a mock. A mock is a programmable stub. And this is what from Jest or from Sign-On or other mocking libraries. You tell it when you call this function with these arguments, return this value. And then you can also in test do verification. Expect this mock to have been called with these arguments, this number of times. And the test will fail if the mock was not called as expected. A fake is a different thing. A fake it behaves exactly like the real thing, only it's implemented differently. So if I want to use, I want to save products somewhere, then I might have a product repository, and then I will have it implemented once as a MongoDB product repository, which implements all of the needed functionality using MongoDB. And then I would have an in-memory product repository, which just has an array of products. It's a class with an array of products, and it just adds to this array, it mutates this array, it fetches stuff from the array. And everything that you can execute against Mongo, you can also execute against an in-memory repository.
So you kind of need to also, I assume, write tests for this fix to verify that your fix works correctly.
Yes. So what I do is I write a test that makes sure that the real repository works correctly. So for instance, this test runs against Mongo, and then I abstract away the implementation and I run the same test again against the in-memory implementation. So the same test runs once against the fake and then again against the real implementation. And if the same test passes against both, then they are both equivalent.
For that specific test?
For that specific test. But recall that I'm doing TDD. I'm only implementing things in order to make failing test pass. So there is no other functionality that is not covered by a test.
Yeah, but you're creating the fix in order to enable the test for the application.
Yes.
Oh, so you're saying you only add functionality to the fix as you need it for the application.
Exactly.
And you implement the test, you create a test for the fix by making sure that at least once it works as expected with the real system, then make sure that it works the same with the fix. And then you can use the fix with your actual code that runs in the layer above and needs to pass, let's say, whatever test is being developed in the context of.
Precisely. So what we actually have, we have two types of tests. We have slow tests and we have fast tests. The slow tests are the end-to-end, and these fake/real tests, which I call contract tests, they usually would run against, something like Docker, or in case of Firebase, it runs against the Firebase emulator suite. And then the fast tests are component tests and unit tests. These are tests that only work in memory. They have no I/O at all. No I/O. They use, use JS DOM, and they use React testing library, but no I/O. And because they have no I/O, you can run all of the tests in parallel, or some of the tests in parallel, and none of the tests impact any other of the tests. So no fast test has any capability to impact any other test. There is no leakage. Everything is completely isolated.
So effectively, the purpose of those fixes is to mitigate costs. The cost both in terms of runtime costs, just the amount of time that it takes you to run the suite of tests. Again, if all the development is test driven, then tests need to run fast. Otherwise, it's going to get in the way of your development process.
Yes.
And also, I assume, to mitigate cost of potentially more resources that are needed in order to work with the actual systems. By the way, if I want to study more about TDD, about fixes, about the other methodologies, and, aside from hiring you as a consultant, where should I go? Where would you recommend that I go and find out more about this stuff? I mean, we mentioned the book.
Yeah. So first of all, it's a fake. It's not a fix.
Oh, sorry.
It's a fake. So the plural of fake is fakes, but it's a fake. It's not the real one. It's a fake one, a fake repository, a fake data access object. So I didn't actually invent any of this. This is things that have been done since at least the mid 90s. I think a very good place to start would be the book that we talked about, Growing Object-Oriented Software Guided by Tests. The problem is that it's in Java and it's very old. So a lot of modern day developers might have an aversion to doing stuff in Java. But Martin Fowler has a second edition of his refactoring book, which is in JavaScript. And if you look at refactoring, the book, second edition, you will find a lot of what I've been talking about here. And Twitter is a very good source of information for kind of discussions. You have people like Martin Fowler, Robert C. Martin, Uncle Bob. You have JB Reinsberger tweeting a lot about TDD, and other guys. A lot of the people who are behind the Agile Manifesto and behind the original TDD movement, in 20 years ago, they are still active, and they are on Twitter, and they are actively engaging with people and trying to teach them and help them understand the methodologies.
So when you come into an existing project, because you said that most of what you do these days is try to help companies deal with their technical debt, with their ball of mud, I assume most of the software was not written with TDD and probably doesn't necessarily have such good test coverage. So what do you do? Is it all about trying to create as many tests as possible, as quickly as possible? That kind of seems like, really hard, tough going as something to begin with. So what is your approach in that type of a situation?
Yeah. So again, the approach is not something I invented. There's a really good book about this called Working Effectively with Legacy Code by Michael Feathers. Again, it's from 20 years ago or something. The examples are probably not relevant, but the concepts are the same concepts. So if I approach first of all, if I approach an existing system that was written in TDD, then no one needs me there, because if it was written in TDD, then it's changeable by definition. If someone called me in, it's because they are unable to change their software and they need help to make their software changeable. So where would we start? So I approach this something like, restoring a very old building that you need to keep the external walls intact. You need to keep the entire facade intact, but you want to replace the innards. You want to replace the piping. You want to replace the electric wiring. You want to maybe install an elevator. So you want to keep the external shell in place, but you want to be able to change the inner workings of the software. So we start by writing an end-to-end test. Now, in many cases, it's not going to be a good end-to-end test. It's going to be a disgusting end-to-end test because the system is disgusting. So the test is going to have to be disgusting. A lot of compromises might have to be made. We might have to keep some parts of the system untested, or we might have to test them manually to begin with, because we don't have any ability to write tests for it. For instance, one of my clients has an Internet of Things system where the software is running on an embedded computer that is hung from a construction crane in construction sites. So you can do an end-to-end test. Like you can install a device in a laboratory and start hooking up, things to its GPS and its camera and its weight sensor, but it's not going to be easy. So in that case, for instance, we just didn't do that. We wrote fakes for each of so we started by wrapping all of sensor data with adapters, and then we faked these adapters, and we wrote only what I call acceptance tests. So earlier I mentioned the concept of a hexagonal architecture, which is basically when you take all of your I/O and you wrap it in adapters, and then you inject the adapters into the software from the outside. Once you do that, the software doesn't care about how the adapter is implemented, and then you can change the adapter from adapter that acts as a specific chip that implements GPS to something that you just tell it what the coordinate is, or that always returns a constant coordinate. And then my first goal when I'm trying to approach a system that is hard to change is to add some layers of safety, preferably an end-to-end test. But if I cannot do that, then I won't do that. And then I introduce hexagonal architecture. I refactor the system to hexagonal architecture to be able to inject fake implementations for all things that do I/O, so that I will be able to control them, that I will be able to write deterministic tests that always behave the same way, that are never going to be flaky. And then I can start refactoring. Once I have a suite of tests that run against the hexagon with the fake adapters, I write, a few tests, a few dozen tests, depends on the complexity of the system. I cover most of the important functionality with this kind of tests, which are going to be fast tests because they use fake adapters for all I/O. They can run in parallel. They can run, if you use something like Python or Golang, they can run in under 1 second, in a few hundred milliseconds. And then I'm free to refactor because I know I'm safe. I know that all of the important features of the system are covered in tests that can run in at most a few seconds. And then I can just, run the test framework in watch mode and start refactoring. And if something breaks, I immediately have feedback that I broke something.
So there's really no way about it. It has to begin with writing a sufficiently detailed suite of tests. You can't really start refactoring before you have at least the minimal coverage that you feel safe with?
Minimal is a very important word because it's a matter of risk mitigation, right? You can skip some of the tests if you rely on manual testing for making sure that you haven't broken anything, or if these features are not as important as other features. So it's not like you can't work around it, and you can always try to refactor without tests, but it's kind of like walking a rope without a safety net.
Oh yeah, for sure. Part and parcel of my work, as our listeners probably know, I mostly do stuff that's related to performance. So very often my job is kind of like approaching some pre-existing piece of software that effectively works, but whose performance is not up to par, and then start banging on it or telling other people what to bang on in order to make it faster. So it's almost always taking existing software and modifying it. And undoubtedly, without, if the software doesn't have the appropriate tests associated with it, then I'm scared shitless. Yeah. And tests need to be there. Without tests, I really, like you said, kind of flying blind. And then, for example, right now I'm helping a team work around the fact that their use of React context has resulted in a lot of unneeded re-renders. And along the way, we broke quite a number of tests, and we're still breaking tests. It's not done yet. But, without the tests, we would have shipped broken software because it renders the first render, let's say, is wrong, but then you get the second render, which kind of fixed it. And I'm trying to get to the final state without going through that intermediate wrong render. And it's not always such a trivial thing without the appropriate tests.
Yeah. So I think we're talking about two types of tests, right? The first type of test is your regression suite. And if you did TDD, then all of the TDD tests are part of the regression suite. The second type of test is more specific, and it might not be a black box test anymore, right? Because you're saying, I want to make sure that there is only one render, for instance. I want to count the renders. This test has to know something about the framework that is rendering to be able to spy on the rendering process, for instance. So you use two types of tests. One to make sure that you are still safe, and the other to exert some new requirement on the system that is more specific. It's more nested. It's more.
Yeah, and it could be fairly challenging because, like you said, with an end-to-end test, you kind of look from the outside on the entire system as a black box. So if you've got two renders, but the second render brings it to a correct situation, then there's a good chance that the end-to-end test will pass, even though the implementation is subpar. So that's not sufficient. On the other hand, also the unit test, which works at the component level, is also potentially insufficient because the component just that functional approach to components that React brings, each render in and of itself was correct. It just got incorrect data as an input. Mm-hmm. So testing at the component level is also insufficient. So you kind of need to find a way to test the system as a whole, but with, like you said, with insight into how that system operates. But so out of interest, how would you go about something like that?
I think it's exactly what I said earlier. I would use hexagonal architecture to fake out all of the I/O. And once all of the I/O is faked, and if you use functional components, if you use React hooks, then the entire rendering process is synchronous. And since the entire rendering process is synchronous, you can use the synchronous query methods of the React testing library to make sure that the first render has the correct data. So for those of you who are not familiar with React testing library, there are three types of queries in React testing library, which are called query by text, query by test ID, query by role, for instance. And then you have get by, then you have find by. And the difference between them is that query and get by are synchronous and find by is asynchronous. Find by does wait for, it does a busy wait. So it looks for something, and if it's not there, it will delay, and then it will look for it again and again until a specified timeout has passed. So, for instance, a find by would pass this test, right? Because eventually the application, the screen gets to a correct state. But the get by will expect the system to be at the expected state after the first render. After the render, it will not do a render.
Yeah,
it will not wait for a render.
Yeah, but in particular, again, I don't want to go too far into the rabbit hole, and we are also starting to run out of time. The complexity here stem from the fact that it used context. So effectively, when you're any component that does the use context will re-render anytime any piece of that context changes. And then some of the changes to the context were done in use effect. So you can see we were heading down a fairly bad direction just from that description.
Yeah, but again, if your test does not wait for any re-render, then it will fail immediately, which is what you want to do. You want it to fail immediately.
Yes, that is true.
I want to talk about the billing aspect of this doing by the minute tracking.
What interests you in this aspect?
Well, so you're a software engineer. There's context switching. I've never billed by the minute ever. I've always either billed by, I think the least I've ever done is billed by the quarter out, 15 minutes. I don't think I did that more than a couple times. Pretty much, I sit down, I look at the clock, I put something in a spreadsheet, and then when it's over, I go to the spreadsheet and then I round basically to the half hour. If it's something where, if I were to have a 7-minute phone call where it was an important 7-minute phone call, it was a billable 7-minute phone call, I would just bill for the hour on that day, because the context switching and everything, the having to get into whatever it was that client needed, stop what I'm doing, move over. So if something is urgent, then I would just bill more. And so I'm really curious as to how you justify the time that it takes you to manage minutes rather than just say, okay, well, I'm going to bill you for an hour for today or half an hour today, rather than getting down to the minute.
The answer has several parts. First, I don't build. I mentor, I pair program, I work with engineers that work for my clients. That I never build stuff on my own for my clients. The only thing that I built in the past couple of years was the Chronomatic software, because it was for me. I was the client. Other than that, everything that I do is pair programming or code review or, design review, stuff like that. And since I have a family, I'm also an active musician. I don't have a lot of free time. I don't have a lot of time at all. We're actually sitting inside my music studio right now, Dan and myself talking, and I have my gear working because before Dan came, I was working on a song. So I do context switching quite a lot. So for instance, one of my customers would send me a pull request. And, I've finished with dinner and we put the kids to sleep, and then now I have some time. So I would go to the email, I would open the pull request, I would start the timer, I would code review, and then I would stop the timer. And since all of my clients, or most of my clients, pay in advance, they buy hours in advance, then these, 7 or 9 or 11 minutes, they go off the balance that my client has already paid for. So it's a kind of a different approach to mentoring or to remote work.
It seems like it would cost you so much to take 7 minutes. And maybe you charge $500 an hour. And maybe that makes the 7 minutes worth it. But it just seems like that's a lot of overhead that you're going to be dealing with to deal with 7 minutes of work or 14 minutes of work, or even if it's 2 hours and 5 minutes. It just seems, in that case, I'd just round down to 2.
Or at the very least, you need to be very aware of exactly when your time starts and when your time finishes. If you have a significant code switch, then let's say you're reviewing a pull request, and you need to kind of figure out where it is, what it's about, because you haven't looked at that code for a while, because it's been a while since that customer contacted you, then you kind of need to factor that into your time slot.
Yes. So if this is the case, then I'm starting the timer and then I'm starting to look at the pull request. And if it's a rabbit hole and I have to do a checkout and start an IDE, then so be it. So I might say, you know what? I'm not going to do it right now. I'm pausing the timer. And then tomorrow morning, I'm going to resume the timer. I'm going to resume the work. Since none of my clients rely on me for any mission critical work. Everything is, mentoring or working with people. I'm not on the critical path. And because I'm not on the critical path, it's never urgent. I haven't had an urgent call since I left Wix, which is one of the reasons why I'm doing this. I don't want to do urgent stuff. I want to do proper stuff.
The important stuff, not the urgent stuff.
It could be urgent and important, but I don't want to do urgent anymore. I'm not in a phase of my life where I can do urgent stuff. Maybe I will be in the future, but right now I'm not.
I guess that makes sense. It's just, to me, I guess the main thing is context switching, and maybe you're a lot better at context switching than I am, because I round up to account for the context switching, because anytime I am switching my brain from what I was doing to something else, it's going to offset me by some amount of time before I can, I guess, get back in flow of something else.
I'm just bidding for the context switch.
No, but I think the main context switch, perhaps that AJ that you're thinking about, is actually the context switch after the time slot ended, because the context switch into the work, well, that's effectively part of the work. The question is not when you press the start button, it's when you press the stop button, really, I guess.
Yeah, but again, if it's something short, if it's like a code review, like a pull request review, then it's going to be usually in the evening. And after I'm done with pull requests, I'm going to sleep, or I'm going to watch some TV, and then I'm going to sleep. So context switch is just reading a book and going to bed. It's like switching off the context. Rarely I have to do several context switches in the same evening. It's rarely that I have, 2 pull requests awaiting from 2 different customers. It doesn't happen a lot.
Okay, so between the music, what is it that you spend most of your time for making, and where does most of your income come from?
Software.
And you are 100% freelance.
I am 100% freelance. I spend something like 2 to 3 days a week doing consulting, and something like 2 to 3 days a week doing music.
But the music is not paid. That's just
it's break even at this point. We really hope to make it more successful, but at this point the software income pays for the music career mostly. Okay, so you just have a good fee schedule where you can work 2 to 3 days a week and provide for all of your needs, and so you I'm guessing you dedicate a full, somewhere probably between 8 and 12 hours on a day. 6 to 8, but yes.
Okay, so you are really living the dream then. I mean, you've got.
I don't know. I don't work that way, and I'm pretty happy with where I am.
Each has their own dream. It's. I don't know, man. Like, I used to be an engineering manager working full time, and I was happy. But then, I had kids, and I didn't want to give up music, so I had to give up something. So I just gave up my career.
Yeah, I don't know if I would say that you actually gave up your career, because first of all, you still work at it, so it's still a career. You're still
well, it's what makes your money.
Yeah, and I think you also really enjoy it. Otherwise, we wouldn't be here talking about it. So I would still consider it a successful career.
Yeah, it's just not the career I had. It's not the career track I had 5 years ago.
Oh, yeah, for sure. You changed. But I think that's something we all do throughout our career. I think if I look at, I'm still working for the man, but if I'm looking at the type of roles that I'm looking for, and the type of advancement that I'm looking for, it's very different than it was, let's say, a decade ago, even though I worked at a large company then, and I work at, well, not a large, at a medium-sized company then, and I work at a medium-sized company now, and I'm not my own boss, still, the type of work that I do has changed a lot, and it's still software. Anyway, we need to evaluate where we are at various points of times in our life and decide what's really important for us. That's for sure.
Yeah, I might start a startup company when I'm 50. I don't know, like, I'm 42 now. I don't see myself doing that in the near future, but who knows what's going to happen when the kids grow up.
Yeah. Well, I'm curious, with that lifestyle, do you feel good about your retirement as well with the track that you're on?
Well, right now my retirement fund is down like 50% because of, NASDAQ, but yeah. I have the privilege of having joined Wix at a very early stage, and I cashed out pretty nice. So I always have that to fall back on, but I'm trying and I'm succeeding mostly not using that money at all. So that's my retirement fund, really. Okay, cool. My formal retirement fund is down to nothing but my informal retirement fund is also down, but it's in a better shape.
Okay, cool. I mean, I think that is, to me, that's really interesting. That's really interesting to actually be working 2 to 3 days a week and making enough for yourself. And I think that actually provides a really good backdrop for a tangible value to the patterns that you've discovered. Because it's not just, hey, God, this is really good and it helps and I tell businesses to do this and that, but this is so good that it allows me to work 2 to 3 days a week and have my expenses met and feel good about my future. And I think that as a backdrop for talking about writing changeable software and the importance of it, to me at least, speaks volumes more than just the technical aspect alone, but the cumulative value of what you're doing.
Yeah, I guess. It's not exactly true, I think, because the value that my value proposition is for my clients, and my clients don't work 2 to 3 days a week. But it is true in the sense that because you are very safe always, you always know that you can change your software, then you can always, make yourself redundant. You can, as an engineer, as a tech lead for a team, if the team does TDD, you can go on vacation for a month and not worry that when you're back, everything is going to be broken.
You remind me of an amazing scene from The Office where Michael Scott, the boss, is walking out with his boss to a meeting, and he tells her, and he turns to all the employees and say, well, I'm leaving, so you can all go home now. And she turns to him and said, like, what do you mean that, said, oh, they can't do anything without me. And then she looks at him and he goes, oh, wait a minute. They actually work better without me. And then he thinks about that and he goes, oh, like he keeps on digging himself into a hole. But yeah, it's an interesting thing about the fact of us making ourselves to an extent redundant. Again, going to my own personal experiences, it's about getting the performance to a certain point and the systems that monitor the performance to a certain point where I'm no longer needed for that system anymore because it has good performance and it has system in place to prevent performance regressions. And yet I'm nowhere near to being out of a job. That's all I can say.
Hey folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Okay, so with that, I think we'll wrap up our conversation. We're sort of getting a little long on time, and we will move on to picks. Picks are part of the podcast where we get to talk about other things if we want to. Books, food, movies, some show you went and saw, whatever. And so today we'll start with our long picker, AJ.
That's just excellent, Steve. That was an excellent choice. So the first thing I'm going to pick is The Lost Metal. This is the final book of Mistborn Era 2 by Brandon Sanderson. It hasn't come out yet, but the reason I'm picking it, or maybe I should pick Tor.com's book previews. I guess that's really what I am picking. You can both read and listen to, you can read up to chapter 10 and I think listen to up to chapter 4 or 5. Maybe it's even a little bit further than that on the Tor website. Tor is the science fiction fantasy universe publisher. They have The Lost Metal up for preview. So I haven't actually started yet, but I mean, it's the final book in this segment of the series, so it better be good.
Yeah, my problem with Brandon Sanderson is that it just takes too long between the different books. So by the time a new book comes out, I've totally forgotten what all the previous books were about, who the characters are, and then it becomes a question of am I willing to put in the effort to reread it again, especially if it's not the last book in the series. So I know I'll just have to reread everything again the next time another book comes out. And, it gets old at a certain point.
It's factorial reading.
Factorial, exactly. And I'm not a factorial person. So, it gets tiring.
So I don't disagree with you. We thought that it was a trilogy because originally it was a trilogy. We didn't know that it had silently become a quartet. Is that, or quint? Yeah, that's what you call it, right? So we went in believing that we were going to get to the end, and we're very disappointed to find out that he had decided to split the story down a little bit further. But in general, I agree with you. I prefer to read a series that's been finished, and I've been burned. Well, my wife has been burned. I didn't get burned because I realized I don't know if this is going to be able to pull together and stop. But there was another series, not Brandon Sanderson, that we started on, and then the author. I know which
one you mean.
The Name of the Wind.
Exactly.
Yeah. Name of the Wind.
I think he literally admitted failure, inability to finish that series of books.
I did watch a video where he didn't quite admit failure, but he said he wrote the last book and then threw it away, wrote it again and threw it away, and isn't certain when he's going to finish it. So
it could be worse. It could be J.R.R. Martin with, that series of books, Game of Thrones.
So apparently that one's actually called A Story of Ice and Fire, right?
Yeah, whatever.
I think that's actually the name of the series.
Either way, I don't know if he's ever going to come out with the next book, but I'm not going to read it. And I've read all the previous books. It's just, I just can't go there anymore.
All right. So that was one pick, and I had at least one more, but I don't remember what it was. I think I was going to pick a TV show. We started watching Surviving Death on Netflix. The first episode was really, really good. The next two episodes, so I don't know if I can pick the series, but the episode, at least from Surviving Death on near-death experiences, I thought was really cool because it was doctors and scientists. It was people taking a very pragmatic approach towards it. And of course, I like it more because they basically came away saying consciousness must exist outside of the brain because of all these cases where people have been brain dead and been able to describe things that were too accurate for someone who literally has no oxygen in their brain and no heartbeat and has their eyes closed laying down on a table. There's no explanation for the multitude of occurrences of people having near-death experiences that are so similar across cultures and that have so many details of this out-of-body experience that are so accurate and the fact that people are doing anything at all. Because even if you were to say it's a dream, well, how does somebody that has no oxygen, no heartbeat, and has literally been dead for 15 minutes, how are they having a dream? Which I guess there's the whole time, the whole inception principle that maybe they had the dream in the last 1 second. But anyway, so I thought that was pretty cool because of the scientific approach and the skeptical approach. But then also so many skeptics be turned to saying, well, maybe consciousness is outside the brain. I thought that was really neat. And that's all I'm gonna pick for today because that's all I got for today.
While we're talking about death, I would like to make a reminder of a famous quote by the guy named Vicini, which is, "Never go in against a Sicilian when death is on the line."
That's a good
For those of you who don't know, that's from The Princess Bride. Anyway, So with that, we'll move on to Dan. Dan, you got picks for us?
Yes. So I'm going to pick a TV show, and I think I actually already picked this one, but we're enjoying it so much, I'm going to pick it again. And also because the second season, which we just finished watching, turned out to be as amazing as the first season. So the show that I'm talking about is Fargo. It's not new. I don't know why it's taking us so long to actually start watching it, especially given that we love the movie. By the way, the movie is just amazing. But it turns out that the TV show is also amazing. So the first season was just awesome. Then we started the second one, which is like a total different, one of the characters, but a totally different in the same location, but a totally different time period. And it started kind of slow, and we were thinking about, is it going to be as good? And it finished on a definite high note. It was amazing. And now we're starting to watch season 3, and it's also wild and wacky and out there. And so far, I can't recommend this series highly enough. So if you've got the opportunity to watch Fargo on TV, highly recommend it. So that would be my first pick. And my second pick is my usual downer, and that's the ongoing war in Ukraine. It's just so bad now that the Ukrainians are able to push the Russians back. So the Russians are retaliating by intentionally targeting civilians and civilian infrastructure. This is just, literally crimes against humanity. There's nothing else to say about it. And so whatever you can do, our listeners, to help these people in need, please do so. So those would be my picks for today.
Okay, I will go next with the picks. First of all, before I get to the high point of every episode, the dad jokes, I have an interesting blog post that I saw today on Hacker News. One of the pretty well-known tool that GitHub has come out with over the past, year or two, I forget, it's called GitHub Copilot. And the basic gist of it is that it's a tool that does code suggestions for you. And the way the data source they use is all of the open source repositories on GitHub. And so there's been quite a number of questions and issues raised with doing that specifically regarding licenses and whether they really should be able to use that other people's work for their own benefit in such a way, especially now that they're charging $10 a month for everybody to use it.
Well, I guess if they exclude repositories that are GPL'd, I think that they're mostly okay. I assume their lawyers are validating everything they do.
Well, that's where I'm going. There's an interesting blog post that's written by a guy named Matthew Buttrick, who is apparently a lawyer and a developer. And it's a website called GitHubCopilotinvestigation.com that's investigating those exact issues and how GitHub and Microsoft seem to have sort of, we're good, don't worry about it, we're okay. And so anyway, just some interesting reading along the lines of other issues that people have had since Copilot first came out. And now for the dad jokes of the week, and I'm hoping that my sound effect works as it should. It seems to be a little delayed, but oh well, some sound effect is better than no sound effect. So, often you'll hear women say that one of the most painful things they've ever gone through is childbirth and the pain of delivering a child. Me personally, I've always heard them say, like I said, that it's the most painful thing anyone can experience. Maybe I was too young to remember, but I didn't think it hurt that much. Thank you. So starting to, get close to Christmas, started thinking about Christmas gifts and stuff. And so I was in a department store looking for a gift for my wife. And I asked the clerk, hey, how much for the funny smelling spray? And she said, perfume? And I said, no, per bottle. And then finally, on the subject of food, what do you give a cannibal who's late for dinner? The cold shoulder.
That's actually okay.
That's okay. Okay, I got a little bit of approval there. Okay, so with that...
That's gross. That was so gross.
We'll move on to Shai. Shai, did you come up with any picks for us?
Yeah. Can I do one technology and one non-technology pick?
You can do whatever you want.
Yeah, exactly.
Okay, so I can maybe do several. So technology-wise, I started using Vite and Vitest specifically.
Very good.
During the Chronomagic project, and I was very impressed. One of the pain points I had before with, Jest is that Jest was configured one way, and then, TypeScript compiler was configured a different way, and the module system didn't work exactly the same with Jest and with TSC, and then you would have a lot of need to reconfigure everything twice. Once in tsconfig and then in Jest config. And in Vite and in Vitest, it's just gone. Just one single config, everything works. And it's not perfect yet. It was several issues with debugging in VS Code, but I was very impressed, and I highly recommend people to move away from Jest and towards Vitest.
So out of curiosity, you mentioned you're debugging in VS Code. Are you talking about debugging your JavaScript or in particular what debugging?
Yep.
So do you use your browser dev tools, or do you use one of the debugging configurations in VS Code where you do it right in the IDE?
Yeah, so I'm debugging code that's run from tests. So it's always inside the IDE. It's a run configuration in VS Code, and I haven't managed to get it to work with Vitest yet.
Okay.
Shai is, like I said, Shai takes TDD and testing seriously. That means he doesn't really need to debug, let's say, I call it code in quote unquote production. He debugs code in tests. in order to pass the test?
Mostly. But I make a joke that I don't need to look at my software. Like I'm writing front-end software. I don't need to see it working to know that it works. I rely on the tests. Later, I would look at it to do some styling and CSS, and whatever theming, but it's not the important bit. So that's one. That's Vite and Vitest. It's spelled V-I-T-E, but it's like French, I guess. So it's Vite and not Vite.
It's like fast in French because it's also supposed to be really fast.
Yeah, it's really fast. Yeah. So that's one. We were talking about books, like science fiction book, and we were talking about consciousness. So my next pick is really appropriate. I recently started reading the Bobbyverse trilogy. 4 books, I think, at this point. The first book is called We Are Legion, We Are Bob. I don't know if any of you have heard about it.
No.
It's a very interesting book. The premise, and I'm not going to spoil anything because it's like in the description on Goodreads. The premise is a guy just sold his software company and he steps into one of those companies that do cryogenic freezing of the brain after death. And on his way out, he's run over by a car and dies. And then he wakes up in the 22nd century where they restarted his brain on a computer. And now the world is run by different states from the one that were existing when he died. And they are sending him as a space probe to outer space to what's known as a von Neumann probe. It's a probe that goes out to space and mines resources and builds more copies of itself. And this is a case where you have a mind running not on meat brain, but on a computer brain. And then the story evolves and evolves again and evolves again. And it's very nice. It's very interesting. It talks about questions of consciousness and of the self, but it's also nerdy sci-fi. If you've read The Martian or Project Hail Mary, then the style might be familiar to you. Nerdy white men sci-fi. But it's
nerdy sci-fi-ness has no color.
It can only be written by middle-aged white American male. There's no way any other type of population would write this sort of book. But yeah, he wrote it in his
Don't put people in a box now. Come on.
But I really enjoyed it, and I really enjoyed it so much that I'm already in book 3, and I already started the series like a month ago.
What was it called again?
We Are Legion, We Are Bob.
We Are Legion, We Are Bob. Okay, that does sound pretty interesting. I did actually listen to Project Hail Mary last week. I have no idea how that got done in just a week, but I listened to the whole thing.
It's a page turner. How do you say page turner in audiobook? But I actually read on a Kindle. But yeah,
I think you still say page turner.
Yeah.
Well, so yeah,
fast forwarder.
Well, a 2Xer? No, that wouldn't make sense. But I would say Project Hail Mary. After reading and listening to so much Brandon Sanderson, it's really hard with other books because other books pretty much sound like they're for children. They almost feel like caricatures of people rather than people. And Project Hail Mary was fun, but it was cartoonish. The way that the characters were presented was cartoonish compared to Brandon Sanderson.
Maybe you should also read more fine fiction.
Well, I also read, when I was younger, I read Jurassic Park and I just re-listened to it. And I would say the same thing about that. The characters felt much more like caricatures. The movie was much better.
Because that was never the point with these books. Michael Crichton, what's his name, is not known for his fine writing. He's known for his really interesting ideas.
Fair enough. I did enjoy Project Hail Mary. It was good. I'd recommend it.
Do I get a third pick?
Sure.
So I'm going to pick something old, but it's an album that I think everyone should listen to. It's not a death metal album. It's by an artist called Agnes Obel. She's from Denmark, but she currently lives in Berlin. She does music that like no one else does. It's a very, very specific genre. And her third album is called Citizen of Glass. And it's an album with no drum set, with no guitars, with no bass guitar. It's just piano instruments and string instruments and a lot of vocals. And it's one of the most beautiful things I've ever listened to. And whenever I'm on a plane and I want to just tune out and immerse myself in an experience that would soothe me, I play Citizen of Glass by Agnes Obel, and I'm in a world of my own. So everyone should listen to that.
Alrighty. So with that, we will wrap up this episode. Shai, if people want to contact you or get a hold of you or give you money or anything like that, where's the best way to follow or contact you?
Yeah, give you money. Twitter. I'm Shai Yalin on Twitter, ShaiYallin, or just look at the description of the podcast.
And I have to say that Shai Yalin is definitely one of those people on Twitter that you want to follow if you're interested in technology and software development and the craft of software development.
Excellent. Well, thank you for coming, Shai. This has been a great and long conversation. We always like having Dan's friends on because they know their stuff for sure.
Bandwidth
so
for this segment
with that,
is
we will
provided
wrap
by
it up.
CacheFly,
Thanks
the
for
world's
listening,
fastest
everybody.
CDN.
We'll talk to you
Deliver
next
your
time on
content fast
JavaScript
with
Jabber.
CacheFly. Visit CacheFly.com to learn more.